for instance. And Luria and Myron, this is a map from Myron coming from task switching literature, so they applied their logic to these timers as well and used an explicit cue telling you in advance about in which order you will have to respond, and changed the interval, how much time do you have for preparation, and what are the effects of that. And they all suggest that we have good control over the processing order. We can prepare for processing the task in a certain order. One thing De Jong has shown, and which is not directly evident, is what task order is easier. If you think of this mechanistic model, suppose this, in brackets, is one trial. First auditory task and visual, or task 1, task 2, whatever you name it. Then you do task 1 first, switch bottleneck, do task 2. Now the bottleneck is set to process task 2. So maybe that it's actually easier to do the next trial in the opposite order. First task 2, then task 1, because the bottleneck is still set to this. But he found we actually automatically prepare the same order. So automatically it's reset to the order we did before. So doing auditory vision, auditory vision, auditory vision is easier than auditory vision, visual auditory, vision. That's the idea. Okay, I will really hurry up now. When we do MRI research, put that paradigm into the MRI, then one important thing I would like you to remind about is that the level of MRI signal tells you something about how much neural activity there is. So that when we have an easy task, we expect only little MRI activity. For a difficult task, we expect higher activity. Okay, and what we did was actually doing that paradigm in the MRI. And one thing we have to think about is, how do we do the data analysis? What do we compare with what? And the theory is either the dual task is just the sum of the two component tasks, or it is the sum of the two component tasks plus some executive function. And if we want to test for that component, what we can do is we can say we do the dual task, subtract both single tasks, and test whether it's larger than 0. Or, stated differently, whether the dual task is more than the sum of the component tasks. If that is true, we should find something in this comparison. And that's exactly that comparison of this PRP study. And you see, this is the top left view on the brain. There is extended lateral prefrontal cortex activation in the left and in the right hemisphere here. And this activation is beyond, is additional to the one which you would have by doing the component task. In this study, we were also able to show that it's spatially distinct. So when you do the tasks by themselves, they have the activations in this area of the lateral prefrontal cortex. They have activation there, but it's very hard to see here. The dual task activation are more along here. So you have a spatial distinction, you have new areas which are activated. New additional areas come into play when these two simple tasks have to be done together. Okay, then, so PRP dual tasks demand additional executive functions, and they are localized in the lateral prefrontal cortex. So then we went on asking what's their specific function. And one thing we already mentioned is the control of the order in which the tasks are processed. So when we have a changing order, we have high demands because we automatically would prepare, and for that order, doing the same again, low demands. So what we did was a study where people had randomly switched the orders, like in task switching paradigm, and compared the activity in order change trials to the ones in order repetition trials. And again, we found the lateral prefrontal cortex in the left and right hemispheres, and we're able to show that in switch trials, activity is higher than in repetition trials. But like in task switching, it's a relative difference. These areas are highly active in trials where we have the same order as well. So to support this claim that it's not only about task order control, we did a study where we said to the participants, okay, just do it in any order you want to. So no specified order, you can do it as you want. These data are still preliminary, and what you see, again, lateral prefrontal cortex, even if they have no restrictions on the order in which to respond. Okay. I think the final study is the idea that the coordination of the two tasks should become easier the larger the SOA. So because here we have a lot of interference, both are nearly simultaneous. Here the natural presentation order already may resolve quite a bit of interference. So we had an SOA of 800 milliseconds and 100. We actually had more, but this is the contrast just between the two. And again, lateral prefrontal cortices are activated more strong. Oh, sorry, must be the other way around. So they are more strongly activated when the SOA is short and less strong when they are in slow SOA. So to summarize that, the POP paradigm offers a very simple and well-controlled dual task situation for investigation. The question whether we need executive functions for these tasks is that the behavioral evidence suggests that probably that is the case, and the fMRI evidence is more clearly saying yes, there is additional activation. And the nature of these executive functions is first, they are additional to the demands of the component task. Its coordination of task order is definitely one of the components, but not the only one, as we have shown. And we have shown that these demands on the executive functions decrease when they are temporarily stretched from each other. Okay. And in a study I haven't shown, we were able to show that these executive functions are actually strongly correlated or linked to working memory function as assessed by an operation span task. So in the MRI we did an operation span and POP dual task, and both activate the same areas. Okay, then thank you very much for your attention. Do you have any questions? Just managed right. Exactly 12 o'clock.
Is the bottleneck found consistently no matter what the task?
Sorry?
Is this bottleneck in terms of the difference in deciding the task, is that consistently no matter what the task given?
Well, that depends on the task itself. So for instance, if you have a simple response task, so you don't have to decide between two or more alternatives, but just if there is a stimulus press, then you observe a PRP effect as well, but it looks different. Because in simple response tasks, you don't have a response selection stage, because you don't have to select anything.
Yeah.
And therefore, the whole thing looks a bit different. But still you would have a POP effect, probably at other stages. But as soon as you have a response selection, you have the POP effect.
Okay.
Yeah, there are numerous studies testing which task demands, like memory recall, give rise to a POP effect. So they extended and they did studies where you only have a single stimulus and you have to respond to attributes of that stimulus. So POP task is again like task switching a paradigm where there are literally hundreds of studies investigating every little detail and computational models of that task and things like that. Okay.